Good afternoon. We are being with the second part of this welded plate girder. So again, I appeal go through these three videos. You will come to know the clauses. I am not going to mention clauses over here because again it will take time for this. So you can go through this and you can see the clauses. Actually, clauses are in chapter 8, or we can say section 8. There you have all these clauses and you have to refer this. Now already we are with this problem and now we have decided this section. We have section, this has 400 millimeters. We have thickness of flange 32 millimeters. Depth of web we have 1300 millimeters. And thickness we have 10 millimeters. So this cross section already we are within first part. Now we have next step number 5. We are with 4 steps over there. So we have in first step, that is given data. Step 2 we have shear force bending moment. Step 3 dimensions of web plate, and step 4 we are with dimensions of flange plate. Now we have first step 5, moment of resistance. And we have this formula, MD is equal to beta B ZP Fy upon gamma M. And we have to go for beta B, that is 1. Now we know we have to consider this part. So this part comes 400 minus 10, 390, and then it will be 195. And we have BF upon TF. Sorry, B upon TF, that is 195 upon 32. And then it will be less than 8.4. And therefore we have beta B is 1. Now we have to find ZP. And we are considering only flange. Sorry, we are considering flange and web. But when we are saying moment of resistance, because we are not going to consider this web, and if we will consider only flange, then we are going to get this ZP, that is equal to, due to flange, we are considering moment is resisted by flange. So we have 400 into 32 multiply by, so we are taking at neutral axis. So here neutral axis and plastic neutral axis we have same. So this we have 650 and this distance we have 16. So 650 plus 16, we are going to get it as 666. So into 666 multiply by 2, because we have this flange on both sides. And then we are going to get this value, that is of ZP, that is equal to 400 into 33, and it comes 17.05 into 10 raised to 6 millimeter cube. Now if we will find MD from this, then we have 1 into 17.05 into 10 raised to 6 into 250 upon 1.1. And we will get this value, that is equal to 3876.36 into 10 raised to 6 Newton millimeter. And that is equal to 3876.36 kilonewton meter 17.05 to the power 6 into 250 upon 1.1. So, sorry, this is 3875. Okay, just check it. 3875, something like this. And then this is greater than, our value is 3605. We have considered only of flange because our assumption is flange is going to resist bending moment. Now in some books they have given a web also, and we have also considered in some problem, and that is of web. That is your choice. You consider or do not consider. That will not affect, because while designing the flange plates or deciding the dimensions of flange plate, we have considered that is flange will resist only bending moment. Then we have next, that is step 6, which is shear resistance of web. So we have step 6. Step 6, shear resistance of web. Shear resistance of web. And then we have this formula, that is VCR is equal to AV into tau B. Now tau B we have to find out. AV we have D into TW, that is of web. So now tau B we have, that depends upon your tau CR, lambda W, and likewise. So we will go one by one. You can go to IS. So we have tau CR is equal to KV pi square E upon 12 in bracket 1 minus mu square. I have committed mistake in some cases. It is considered as 1 minus mu whole square into d by tw whole square. Now we have to find kV, which depends upon C by D, and we have value of C by D. C we have 1600, and D we have 1300. So this value comes 1.23. And D by TW, actually we have D by TW. D we have 1300 and TW 10. So we will get it as 1.3. And then we will substitute these values in this equation. As we have C by D greater than 1, so we have value of KV, that is equal to 5.35 plus 4 upon C by D whole square. And then we will have this value 5.23 plus 4 upon 1.23 square, and we will get this value 7.99. And then we will substitute this value in tau CR. We have KV 7.99 into pi square into 2 into 10 raised to 5 divided by 12 in bracket 1 minus 0.3 square into 130 square. And we will get this value, that is 85.46 Newton per mm square. Then we have to calculate lambda W, that is equal to root of FYW divided by root 3 tau CR. Then if we will put this value, then we have 250 divided by root 3 into 85.46, and we will have this value, that is equal to 1.3. And as this value is greater than 1.2, and therefore we have tau b that is equal to fyw divided by root 3 lambda w square. And we have 250 divided by root 3 into lambda w, we have 1.3 square. And from this we will get value 85.41 Newton per mm square. And now we will go with VCR. So we have VCR is equal to AV into tau B, and tau B we have, AV we have 1300 into 10, and tau B we have 85.41. And from this we will get value of VCR, that is 1110.33 into 10 raised to 3 Newton is equal to 1110.33 kilonewton, greater than 620 kilonewton, and therefore safe. Now we have next, that is step 7. Connection between flange and web. We have VU, we have calculated 620 kilonewton. Now we have tau is equal to tau into B, and which is equal to VAY bar upon I. Now AY bar, we have already taken this on ZP, which is 400 into 32 into 666. You can see over here. So 400 into 32 into 666. Moment of the area above it, about neutral axis, that is AY bar. And then we have value that is equal to 8.52 into 10 raised to 6 millimeter cube. Then value of I we have BD cube by 12. Now BD, I will write first BD cube by 12, and from this I will subtract BD cube by 12. And from this we will get value 1.32 into 10 raised to 10 millimeter to the power 4. Now how we will have this value? So now we have considered first whole rectangle, and this whole rectangle we have actually 1300 plus 32 plus 34, so 1364. So 400 into 1364 cube by 12, and we have subtracted this part. So we are going to subtract 10, so it becomes 390, and we have this as 1300, and therefore we have taken likewise. And now we will find value of tau horizontal, I will say. So we have tau horizontal equal to we have 620 into 10 raised to 3, 8.52 into 10 raised to 6, upon 1.32 into 10 raised to 10. And we have this value, tau h equal to 400.18 Newton per millimeter. Now we have tau v, 40 Newton per mm, kilonewton per meter because Newton per mm, and tau resultant we have tau h square plus tau v square, and this is equal to 400.18 square plus 40 square. and this value comes 402.17 Newton per millimeter. Now, we will consider thickness of weld as our thickness of flange, that is thicker part. Thickness of flange, we have 32 millimeters. Therefore, we will consider, let us, size of weld 8 millimeters. So size of weld equal to 8 millimeter, and we will assume also length of weld 100 millimeter. And now we have strength of weld equal to shear force. Strength of weld equal to shear force. Now strength of weld we have Fu upon root 3 gamma mw into area of weld. And here we have tau r into pitch of weld. Now we have 410 upon root 3 into 1.25. We have throat thickness 0.707 into 8 and length of weld 100. And tau r we have calculated, that is 402.17 into P. And therefore from this we will get P, that is equal to 266.36 millimeter. But we have maximum clear spacing. Clear spacing, that is equal to 12 into 10, 120 millimeter, and weld 100. Therefore, we have maximum pitch allowed. Maximum P is equal to 120 plus 100, that is 220 millimeter. And therefore, provide 8 millimeter weld at 220 millimeter center to center. So now diagram, if you want to draw it, then we have diagram is like this. So we have, this is our web, and then we have this as flange. Actually web we have, that is dotted. I will just rub this. So we have this as dotted. And we have web inside. And then we have, this will be 100. And we have, this will be 100. And this is 120. And so we have pitch, that is equal to 220. So this will be about your connection between flange and web. So remaining part we will see in the next lecture. So thank you.